Okay, so here on our first problem that we're going to graph f given f prime. So this right here, guys, is f prime. And we want to find all of these 6 things, a through f. And I suggest that we actually list those out after we have already sketched out what the graph of f looks like. So the first thing we're going to do is to draw 2 little number lines right underneath our graph. And we're going to label it in such a way that it matches up with the x-axis of our f prime that's already graphed. So I'm going to label these f prime and f double prime. I'm going to do sign charts on these number lines. So let's look at the graph of f prime. Where is the graph 0? Okay, so this is the actual graph of f prime. It has a 0 at 0, so I'm going to put a 0 right over here. Now, what do you know about the graph of f prime when it's less than 0, meaning over here on the left-hand side? Well, it's negative because the f prime value is negative, so I'm going to write in negative. Now, to the right of 0, when x is positive, my f prime values are also negative. So what is this actually going to tell us? That the slope of the graph of f is going to be negative everywhere except for 0. Now f double prime, I'm going to fill out the sign chart for f double prime. What is f double prime on our graph of f prime? F double prime is the slope of f prime. So we need to pay attention to the slope here of our f prime graph. So the slope here on the left-hand side, when x is negative, we have a positive slope. And then it turns into a negative slope. What do you know about the slope here at 0? It doesn't exist because we have a cusp. Okay, so we'll just leave that blank. We don't need to write anything. So now I need to actually figure out what the graph of f itself looks like. So I'm going to draw an xy axis, again right underneath it, and making sure that my x coordinates match up. So I have -2, -1, 0, 1, and 2. Pay attention to this right here. This tells us the 0 of our function. That's really important because I know my graph must cross the axis at 0. So we're going to put in a little 0 right here. Now what else? Over here on the left-hand side I have negative slope and f double prime. In terms of my graph, this is now the concavity of f. Try to remember, f double prime is the slope of f prime, but it's the concavity of f. So it is going to be concave up with negative slope. So what might that look like? And it's got a touch here, so concave up, negative slope. And then all of a sudden at 0, I have a slope of 0. And then it's going to be concave down, because f double prime is negative, with a negative slope. So something like this, and this is going to be the graph of f. Okay, we're going to try another one. Actually I'm going to work across and do example 3 instead of example 1 or example 2. So I'm going to draw and sketch out a number line for f prime and f double prime, keeping in mind that f double prime is the slope of f prime and also the concavity of f. We have f prime. Over here, to the left of -3, f prime is positive, and then f prime is negative until you reach -1. And I can even highlight those for you. It's a 0, a 0 here. It's positive between -1 and 3, and then it'll be negative after 3. So now f double prime, that is the slope of what we're looking at right now. Okay, so we have positive slope on the left, positive slope, all the way till we hit 1, and it's 0 slope because it flattens out and turns back down. And you've got negative slope all the way through. Okay, now I'm going to draw out my xy axes and match up my scale. -1, -2, -3, -4. 1, 2, 3, and 4. Alright, so working from left to, let's pay attention to our zeros. We have zeros at -4, -2, 1, and 5. Alright, working from left to right, I have positive slope concave up all the way till -3. Positive slope concave up. Now notice I have to cross through this 0, so it has to go up, something like that. Then at -3 it switches to negative slope concave up all the way to -1. So I have to cross through this 0, and then I have to have a negative slope over here at -1. This piece translates all the way down here. From -1 to +1, I have positive slope concave up. So I need to continue and cross through this 0. And then between 1 and 3, it's going to be positive slope concave down, and at 3, I have to have a 0 slope. So somehow this is going to flatten out and give me 0 slope, and then it's going to be negative slope concave down, crossing through the remaining 0. Now these graphs that we're drawing for f in the directions are given to be continuous, so make sure that we don't have any holes or asymptotes. Okay? Now I drew out the first two, and now I'm going to list out all my pieces of information. So these A through F up above. I just thought I'd write them all out first, and then, or draw them all out and then list them. So the first one says the intervals on which F is increasing. Take a look at your graph. F is never increasing. So we write never. B, decreasing, -infinity to infinity. Do we have any relative extrema? None. Where is the graph concave up? So it's concave up over here in quadrant 2, so that's -infinity to 0. And it is concave down from 0 to infinity. And the last one, any coordinates of points of inflection. We have points of inflection at x equals to 0, because that's where it turns from concave up to concave down. Now let's go through number 3. Intervals on which the function is increasing. If you want to look at the number line or the sign chart for f prime, you can do that, certainly, or just look on your graph. So it's increasing from -infinity to -3, and then it's increasing again from -1 to +3, and that's it. That's all the pluses for the f prime. So everywhere else it's going to be decreasing. So it's going to be decreasing from -3 to -1, and from 3 to infinity. You have relative extrema, easy to identify, 1, 2, and 3 of them. So we have relative max values at x equals 2, -3, and 2. Oops, nope, that's 3. -3 and 3. And we have relative min at x equals -1. Alright, so those are the top two examples. Let's take a look at the bottom ones now. See if you guys can work on ahead and draw your sign charts. Alright, so f prime. I have it touching here. F prime is 0 at 0. It is positive on the left, turns negative, and suddenly positive. My slope. The slopes are always negative here, and then suddenly we have positive slope. We're going to go ahead and draw our x and y axis and take a look at what our given zeros are. Oops. What our given zeros are. Our given zeros are 0 and 4. 0 and 4. So my graph is continuous and much touch through those points and follow these given characteristics. Okay, on the left hand side we have positive slope concave down. So what might that look like? We have to cross through that 0, so positive slope concave down all the way to 0. Then we have 0 slope at 0. and then it continues with negative slope concave down. Actually, I might want to draw this here a little bit different. And let's see, at 2, the derivative doesn't exist, because look at this right here. F prime is dne at x equals to 2. Okay, so make sure your graph does not have a derivative that exists at 2. It's going to turn into concave up and positive slope, crossing through this remaining 0. So right here we have a corner, so f prime does not exist there. So this is our graph of f. Let's go ahead and list out all our characteristics now that we're here with it. Our graph is increasing from negative infinity to 0 and from 2 to infinity. So it must be decreasing from 0 to 2. Now, as a general rule of thumb, what I want you guys to do is increasing, decreasing functions use closed intervals. Concavity, we're going to use open intervals. Alright, let's see. We have relative extrema. We have a relative max at x equals 0. Relative min at x equals 2. We are concave up from 2 to infinity, concave down from negative infinity to 2, and we have a point of inflection at x equals to 2. Graph changes from concave up to concave down at this point. Last example for today. F prime has a 0 here. It's underneath the x-axis, underneath, all of a sudden above the x-axis. Slope, positive slope, all the way to 1 where it has a negative slope. I'm sorry, 0 slope, and then after that we have negative slope. Then after 2 we have negative slope again, but let's take note that we have an asymptote here. We have negative slope and then positive slope. Our graph has 2 zeros at 1 and 3. Alright, so putting these two things together, starting from the left, working to the right, we have negative slope concave up, all the way to our first 0. So it can't go down underneath here because there is no 0, so I must approach my 0 at positive 1. So negative slope concave up. Then I have 0 slope at that point, and then it continues on to be negative slope concave down until x equals to 2. At which point f prime does not exist. So again, just like earlier, here we have f prime dne at x equals to 2. Okay, very similar. Doesn't exist. So I'm going to have a corner that shows up there, or some kind of cusp or corner. I could have drawn an asymptote, but our directions for these are the functions are continuous. So I'm going to continue to draw this without any breaks. So now I have positive slope remaining. It's going to be concave down for a little bit, and then concave up for the remainder. And there's our graph for f. So you guys have 4 more problems to do for your assignment, and that's what you'll work on tomorrow.